Hello students, today we're going to learn about the unit circle. So the first thing we need to know is how to convert from degrees to radians and radians to degrees. So we've been working with degrees a lot. Radians, just so you know, we use pi for radians and we use a degree symbol for degrees, which you already know. And 180 degrees is equal to pi. So when we convert from degrees to radians, we divide the degrees by 180 and then we multiply by pi. Okay, so let's try some examples. So let's start with 0 degrees. First step, we have to divide 0 by 180 degrees. Then we multiply by pi. 0 divided by 180 is 0. And with the pi after that will be 0 pi, or 0 times anything is 0, so just 0 radians. Now with 90 degrees, first step, divide it by 180, then multiply by pi. 90 over 180. You need to simplify that first. If you don't remember how, you could use Desmos, but 90 divided by 90 is 1, 180 divided by 90 is 2, so 1/2. Desmos, it gives you a decimal, but you could click that button right there, and it will change it for a fraction, and it's 1/2. And 1/2 pi is equal to pi over 2 because 1 times pi is just pi. So your answer for 90 degrees is pi over 2. Now let's try to convert from radians to degrees. First divide by pi, then we will multiply by 180 because pi is 180 degrees. So let's try an example. So for pi, you could simply replace it by 180 degrees because pi is 180 degrees. So there's really nothing you have to do there. Now for 2 pi, we first divide by pi, then we multiply by 180. So the pi's cancel, you multiply by 180. 2 times 180 is 360. Let's try 1/2 pi. For 1/2 pi, you could just also substitute the pi for 180, so 1/2 multiply 180, and what you'll get is half of 180. So 1/2 multiply 180, that will be 90 degrees, which is what we did earlier as well. So there's two ways. You could divide by pi and show it clearly, or you can directly substitute 180 for pi. All right, off to our main topic for today, which is the unit circle. First of all, unit circle is a circle drawn on a coordinate plane. The XY axis you know about, and it is a unit of 1. So this line here to the end of the circle, it has a radius of 1. You could also think of it as the point there is 1, 0. X value is 1, Y value is 0. And all the way around the circle, it has a radius of 1. And why is the unit circle so special? It is special because if we look around it, it tells us all the degrees and radians, and it also matches with a point on the Cartesian plane. So at that point 1, 0, it is at 0 degrees, and if you go in a counterclockwise direction, it is positive. But if you go in a counterclockwise position, so if you go from 0 degrees from the bottom and around, it will be negative degrees and negative radians. So when you think of the unit circle, it's 1 unit away and the degrees go from here. So start at 0, 30, 45, 60, 90, and so on. And then when you get back to here, 330, and then 360, you can keep going. And as you keep going, you just keep adding whatever degree it is. So 360 plus 30 is 390. 360 plus 45 is 405. And it keeps going around the whole circle, and you can get larger and larger, and it goes to infinity. And a little bit later, we'll learn a term called coterminal angles. So the angles that is the same but has a different name, like 30 and 390. It has the same name, it is the same place. They're called coterminal angles. We'll talk a little bit more about it later. Here's another example of a unit circle that you can look at. This one's really nice because not only does it have degrees and radians, it also has the coordinate points on each of those points that you can refer to. Here's another example of a unit circle. It's more simple, but it's nice. Starts with 0, 90, 180, 270, and then back to 360, quadrant 1, 2, 3, 4. And then also another picture of the coordinate plane, quadrant 1, 2, 3, 4. Quadrant 1, the x value is positive, y value is positive. Quadrant 2, x value is negative, y value is positive. Quadrant 3, x value is negative, y is negative. Quadrant 4, x value is positive and y value is negative. And here is another unit circle. As I told you, it could go around this way. It's positive. But if you go the opposite direction, it will be negative. So from 0 to negative 30, negative 45, negative 60, you could see that this 30 matches with this one, 45 matches with this one. It's just a different direction. Same thing for radians. So if you take a look here, positive radians start from 0, also starts from 0, and then negative around until negative 2 pi. We can also match these. Remember, this one is the same as 30, same as negative 330, negative 11 pi over 3. So if we go back to a question from earlier, for example, if we wanted to find negative 1/2 pi over 2, we'll see where that is. Negative pi over 2 is here. We could say that it's negative 90. We could say that it's 270. We could also call it 3 pi over 2. They are all the same. Now, a coterminal angle, once again, this is the initial site. It always starts here and it ends here. This is the terminal side, meaning that it ends. So start here, end here, start here, end here. Because there's two angles, this is the 45-degree angle, this is the negative 315 degree angle. Right here, these two angles are called coterminal angles, meaning they share the same terminal side. Same thing here, from here to 120, from here is negative 240. Initial side, terminal side, 120 and negative 240 are coterminal angles. Here's another picture, an example of coterminal angles. All this picture is saying is that you can go around a circle as many times as you like we talked about earlier, because you go around it an infinite amount of times, and if it lands on the same place, all those angles will be considered coterminal angles. So like we talked about earlier, 390 and 30, they are coterminal angles. And also, just so you know, negative works the same way. If you go around as many negative times or positive times, if you stop there, they are still coterminal angles. The last thing we want to talk about today is the reference angle. The reference angle, you can take a look here. The angle is here. Now let's say you had the angle here. You don't count that whole thing as the reference angle. You just count the missing space here as the reference angle, extra space here, missing space here as the reference angle. These two pictures are the same thing, I'm just with different colors. So for example, let's take a look here. So for 30 degrees, the reference angle is simple, it's just 30 degrees. But for 150, how far away is it from 180? What is that missing space? So 180 minus 150 is 30. So even though the angle there is called 150 degrees, the reference angle for it is 30 degrees. Let's look at 210. What's the extra space from 210 to 180? It is also 30 degrees. So 210 minus 180 is 30. So the reference angle for 210 is also 30 degrees. And similarly for 330 to 360, what is that missing space there? 360 minus 330 is also 30 degrees. So for 150, 210, 330, and 30 degrees, all of them have the same reference angle, and it is 30 degrees.